Hello friends, welcome to second session of chapter number 10, Circle. As you know, in last period we have discussed some very important concepts of circle. The first one was definition of circle. A set of all the points from a fixed point at a fixed distance and the set of these points, and that is our boundary lines, that is known as circle. So center is not a point of a circle, but center is inside circle. Well, we have discussed the second concept, and that is radius. A line segment whose one end point is the center of a circle and the other point is point of a circle, then this line segment is known as radius of a circle and it is denoted by r. Well, we have discussed third concept, and that is known as chord. You know, a line segment whose both the endpoints are points of a circle, then we can say that it is a chord of a circle and it is denoted by line segment AB. Then we have discussed one very important concept, that is diameter. Double the radius is known as diameter. Or you can say a line segment whose both the endpoints are a point of a circle and passes through the center of a circle is known as diameter. We have given three definitions of diameter. The second definition is a chord passing from the center of a circle is also known as diameter. And the third definition was longest chord of a circle is known as diameter. Well, then we have discussed the concept number 5, and that is secant of a circle. A line which intersect the circle in two distinct points. A line which intersect the circle in two distinct points, then it is known as secant of a circle. Then we have discussed the concept number 6, and that is tangent of a circle. A line which intersect, or you can say touches, the circle at one and only one point, then it is known as tangent of a circle. Well, then we have discussed seven concepts, and that is concentric circles. Well, two circles having same center but different radii. Here the radius of a small circle is r1, the radius of a bigger one is r2, but the center of both the circle is same. So two circles having same center but different radii, and they are known as concentric circle. Well, we have also discussed congruent circles. Two circles having same radius but different centers. Here center is P, here center is Q, but in both the case the radius is R1. So friends, two circles having same radius but different centers are known as congruent circles. Then our concept number 9, that is partition of a plane of a circle by a circle. As you know, circle divide plane of a circle in three different parts. First one, set of all the points on the circle, set of all the points interior part of the circle, and set of all the points in the exterior part of the circle. If O is a center, P is any point, if OP is equal to R, then it is known as circle. If OP is less than radius, then we can say the point is inside circle. If OP is greater than R, then we can say that point is in the exterior part of the circle. Well, we have also discussed the one concept, that is, in a circle with center O, radius is always perpendicular to the tangent of a circle. So, in last lecture we have studied 10 different concepts, and these concepts are very important to solve example of exercise exercise number 10.1 as well as 10.2. So before starting exercise number 10.1, we have discussed we have revised all 10 points, very important points of chapter number 10, that is circle. Well, now let us start exercise number 7.1, 10.1. Well, question number 1. How many tangents can a circle have? You know, to solve question number 1, 2 as well as question number 3 and question number 4, we need the understanding of the 10 concepts only. Well, here the concept of tangent is there. You know, circle, tangent mean a line which intersect the circle at one and only one point. Here question is how many tangents can a circle have? You know, circle has many infinite points, and that's why you can draw infinite tangents. So answer is infinite. So how many tangents can a circle have? So circle have infinite tangents because circle has infinite point, and a tangent means a line which intersect the circle at one and only one point, and that's why we can say a circle has infinite tangents. Well, let us start question number 2. Blanks. 4 blanks are given to you in question number 2. Well, a tangent, again you have to use a concept of tangent. To a circle, intersect it in a blank point. Well, you know, according to the definition, tangent is a line which intersect the circle at one and only one point. So the definition gives answer of this question. A tangent to a circle intersect it in a one and only one point. You can also write 1 point. Well, so from definition you can give the answer of question number 1 as well as first blank of question number 2. Now let me solve blank number 2. A line intersecting a circle. So a circle, a line intersecting a circle in 2 point is known as blank. As you know, we have studied this concept in last period, and that is definition of secant. A line which intersect the circle at 2 distinct points is known as secant. So from the definition of secant we can give the answer of this blank. So the answer is secant. So secant is a line which intersect the circle in 2 distinct points. Well, let me start blank number 3. A circle can have blank parallel tangents parallel to a secant at the most. Well, so what is given to you? Tangent parallel to one secant is given to you. Let me draw one secant. Suppose the name of the secant is AB. Secant means, you know, a line which intersect the circle in 2 distinct points. Here your question is a circle can have blank parallel tangents parallel to the secant. So we can draw 2 tangents. This is one which intersect the circle at one point. Here you can also draw this tangent. So this is L this is M, and AB line is given to you, that is your secant. So a circle can have two parallel tangents. You know, you can draw many tangents, but the parallel to a given tangent, parallel to a given secant, only two tangents can be drawn, because it should be parallel to the given tangent. So if you draw a tangent which is parallel to the given tangent, you can draw only two, means maximum at the most two tangents can be drawn which is parallel to the given secant. Very important blank. Well, what is given to you? 1 secant is given to you. And we have to draw tangents, not only tangents but parallel tangents to a given secant. We can draw maximum two parallel tangents which is parallel to the secant. Well, now question number blank number 4. The common point of tangent to a circle is known as, well, we have discussed this thing in last lecture. Suppose this is circle, center O, this is tangent, intersect this point, but this point of intersection, that is known as point of intersection. This point of intersection is known as point of contact. So the answer is, the common point of a tangent to a circle is known as point of contact between circle as well as tangent. So circle and tangent intersect. At this point of intersection is known as point of contact. So here your answer is point of contact. So here we have completed question number 1. How many tangents can a circle have? Then we have solved 4 blanks. The third one is very important, because how many parallel tangents can be drawn which is parallel to the secant. We have drawn the figure. From this figure you can conclude that maximum 2 tangents can be drawn. The point of intersection is known as point of contact. Well, now let me start question number 3. For exam point of view, this question is very important. A tangent PQ at a point of a circle with radius phi, circle meets a line through the center. You know, one line is passing from this center, another one is tangent. So you can say this is point of contact, this is center. So the radius is 5 centimeter. Let me write center is O. A tangent PQ at a point P of a circle. So this point of contact is P. Radius 5 meets a line. So this tangent meets a line passing through the center at point Q. So this point is Q. So that OQ is equal to R. So this distance is given to you. That is OQ, that is 12 centimeter. Length PQ is blank, so here your question is to find out PQ. So read this question, draw figure, use the concept of 10 concept of circle that we have discussed in last period, and then try to solve this example. You know, we have solved one very important concept, that is concept number 10. That radius is always perpendicular to the tangent. So here OP is equal to 5 centimeter, OQ is equal to 12 centimeter. Similarly, PQ is equal to question mark. You know, measure angle OPQ is equal to 90 degree. So we can use Pythagoras principle. So in a right angle triangle, if two things are given to you, you can easily find out the third thing. So we have used one concept of circle, that is radius is always perpendicular to the tangent. So this become right angle triangle, and then we have used a concept of Pythagoras principle. So we can say OP square plus PQ square is equal to OQ square. Because angle P is 90 degrees, so OQ is equal to hypotenuse. So OP square plus PQ square is equal to OQ square. OP square means pi square plus PQ square means question mark is equal to 12 square. So PQ square is equal to 12 square 144 minus pi square means 25. So PQ square is equal to 14 minus 5 means 9, and 3 minus 2 means 1, so 109. So PQ is equal to 119. So square root of 119 is the length of PQ. Well, so we have used one concept of 10 standard, concept number 10, that is radius is perpendicular to the tangent. And then we have used one concept of 8 standard, and that is Pythagoras principle. The sum of the square of the two sides of a triangle, right angle triangle, is equal to the square of the length of the hypotenuse. We have put the value and solve PQ square. How to find out PQ from PQ square? So find out the square root. So square root of 119 is the value of PQ. Well, now last example of exercise number 10.1. So the blank number 3 is very important, complicated. The example question number 3 is also very important for the exam point of view. How to find out the length of a tangent. This PQ is also known as length of a tangent. Well, now question number 4. The question number 4 of exercise number 10.1, draw a circle. And so let me draw a circle. And two lines. You have to draw two lines parallel to a given line. One line is given to you. Let me take this line is given to you. You can also draw in the outside circle. You can also draw a line which intersects the circle. You can also draw a line which touches the circle. I have drawn a line which is in the exterior part of the circle. So you have to draw a circle and two lines parallel to a given line such that one is tangent. So you can draw one is tangent. See, this is given line. This is required line L1 which is tangent of a circle. And the other is secant of a circle. So let me draw which is secant of a circle. So L and M are two lines, required lines, and two lines which is parallel to a given line. So this tangent is also parallel to a given line. Secant is also parallel to a given line. One is tangent and the one is secant. See, the condition are given to you. One is tangent and the other is secant. So this is given line. This is a required line which is a tangent of a circle, and this is also a required line which is a secant of a circle. So friends, in last lecture we have discussed 10 concepts of this circle. Here we have used this 10 concepts to solve one question, 4 important blanks, one very important example for the exam point of view, that is how to find out the length of a circle, and then we have drawn one circle as well as one line. So draw another two lines, one is tangent and one is secant of a circle. Well, so friends, in next lecture we will start exercise number 10.2. Again, some very important examples are there on the basis of these 10 concepts. Well, so in each and every chapter, first of all, we try to solve, understand different concept of a particular chapter, and then we use or we solve exercise. So you can use these principles or a concept to solve different examples. Well, so friends, in next lecture we will start exercise number 10.2. Thank you friends. Thank you.